Okay, so in the next I will start by introducing a new term that you usually probably also know. It's called confidence interval, and that's can be described as a plausible range for a population parameter. Yeah? If you estimate the parameter of a population, the mean value or something, then you usually don't hit it exactly, but scatter around it. And if you report a range of plausible values, yeah, then you can quantify the probability that your measurements hit the mark or not. And this is done. This is called confidence interval. We had this plot yesterday that showed us how a normally distributed probability behaves if we integrate the PDF in terms of within limits of sigma or 2 sigma or 3 sigma and so on. And so that means from -2 to 2 sigma we have 95.5 of all cases. Yeah. So the confidence interval is, since the standard, the central limit theorem tells us that if we want to approximate the mean value of some population, we do this by some sample mean, which is distributed according to the standard normal distribution, which has the same mean value and a standard error of sigma divided by square root of n. And that with these numbers we can compute a confidence interval. Let's say, for example, x bar plus minus 2 standard errors. Yeah? Which means that we are confident that about 95% of all random samples will have a sample mean that is between these two, within these limits. Yeah? This plus minus 2 standard error part is the margin of error. That's what you write down in papers. Okay? Okay, exactly. Yeah. So this is here the. Now the question is, okay, we understand the standard error. That's the spread, the scatter of our x bar. Why 2? 2 is, first of all, it's arbitrary. It's a number. Generally, the confidence interval is x bar plus minus some number c star or c prime or what times the standard error. And this number here is, we have to choose depending on what probability we are interested in. Okay? If we are interested in 68%, then it's about 1 sigma. If we are interested in 99.9, then it's maybe 4 or so. Okay? Okay, here I give some conditions for the confidence interval, which are the same as for the standard normal distributed samples. Yes.
What is the Z name? What is the name of Z?
This is the critical C. Yeah. This and I'm coming to this. This critical value C score. Usually you give a confidence interval with some goal probability in mind. You want to be 99% sure. Okay? Which means if you want to be 99% sure, you need to cover 99% of this area and you need to figure out what is the x value here so that this and this area is in total 1%. So that's our C star. Okay? I define the area, 95%, and that gives me a C star. And yeah, for example, 95%, I need to find the x value, or the value on the x-axis here, such that the area under the curve is exactly 0.95, which means we have a critical value of 1.96, about 2. Okay? Here there are different ways to figure this out. This is again, so your estimate will be this. This is the confidence interval, and the spread is called margin of error.